Hi, my name is Damon Rocha, and this is my board's objective overview. Today I'm just going to cover the 6 board objectives for robotics and embedded systems and how I met those throughout my time at UAT. Starting with objective 1, I was to design embedded systems and robotics to address real-world situations and challenges. I did this through my Soil Spirit rover in that it addressed the demands of agricultural labor through certain automation, which was done via the rover and the user being able to control the rover with Wi-Fi. As for my second project, it was Harvest Hawk, which was I worked on this as part of Production Studio. And in this, I designed the electrical and IoT interface for this project and developed schematics for the microcontroller and custom shield so that we could easily collect temperature, pressure, humidity, and light data and wire this all up together. Now on to Objective 2. For Objective 2, I needed to demonstrate embedded microprocessor skills, such as microcontroller selection, logic design, schematic creation, and all the rest that's here. I did this through 3 projects this time, starting with Harvest Hawk again. In this, I designed the custom PCB shields and helped this with the selection of the ESP32 microcontroller. And then as for digital logic design schematic creation, this AVR final project was I used an Atmega 328P microcontroller to control a strand beast via a stepper motor. I designed the schematic in KiCad and then controlled using low-level AVR programming to move the strand beast forward and backwards. And finally, as part for digital logic, I designed this FPGA 2-bit adder to allow the addition of any 2-bit numbers using Verilog and a simulated FPGA platform. And now on to Objective 3. For Objective 3, I needed to develop vision and sensing systems for use in robotic applications. This was done via my project here, which was a Arduino-based computer controller, which used ultrasonic sensors to do different things on a computer. And so the vision in this was the processing of the data coming back from the ultrasonic sensors to determine the different type of computer actions we wanted. And then for the second version of vision systems, I built this TensorFlow Lite security camera using a Raspberry Pi. And in this, I did real-time person detection and had automated alerting via Discord. It used live camera feed and then passed the camera feed from OpenCV into an object detection model. And using that, it gave a little buffer time to see how long a person was active, and if they were in the detection zone long enough, sent a notification via Discord. Now on to Objective 4. For Objective 4, needed to integrate transducers, actuators, feedback, and mechanical systems into robotic platforms. This, for me, was done via these 2 projects. Again, we have this AVR strand beast stepper, and in it, we had a stepper motor to act as an actuator that would translate signals from the analog to digital conversion into pulse width modulation, and that would cause the stepper to move forward and backward depending on the location you were turning the potentiometer. And then as for the bionic finger, this was mainly mechanical plus an actuator because I designed these fingers from scratch in Fusion 360 and used a real finger bone model to build this out, and then hooked it all up to a servo motor as an actuator, and then fish in line and tendons so that it could flex and return to its original position. Now onto Objective 5. For Objective 5, I needed to apply examples of human and autonomous control systems into robotic platforms. For this, I had 2 projects. For the first one, again, my SIP. In this, I had human control in that a human could use the, use the controller to move the rover back and forth, side to side, start and stop it. But then also autonomous control via this time of flight sensor that would detect obstacles and then try to go around the obstacles given what it detected. And then for this project, it was completely autonomous in that the rover just used the LiDAR it had on top, the IR sensor it had on bottom, and a Q learning algorithm to teach itself to drive and get better and better as it did it, all while making this heat map of the obstacles and thermal hazards. So this rover, more or less in about a 2 to 3 minute time span, depending on its environment, was able to learn how to drive around this on its own without any human control. It could even reset itself if it needed to. And finally, on to Objective 6. For Objective 6, I needed to implement artificial intelligence and data systems into robotic platforms. We again have the Q Learning rover. For this project, I created this Q Learning algorithm, which is a form of reinforcement learning. The rover could develop its own navigation strategies without any human control via figuring out states of the robot based on the LiDAR, any obstacles on any of the directions, and the IR sensor if it found a thermal hazard. The rover could even, if it got to a point where the navigation algorithm it was using was suboptimal, could start itself over and try again and keep going. And then on top of that, if it got to a place where it was good to go, found a good spot to stop, it would stop itself and say, I'm done. As for the next example, I built out this gesture classifier using a fully custom neural network that I built from the ground up in C++ on this teensy microcontroller. For this, I generated a bunch of synthetic data to mock out the different gestures of like move side to side and rotate and stay still. And then had the neural network, which was sitting on the teensy microcontroller, be able to identify those gestures based off of the synthetic data. And that is it for my boards. From here, I want to continue to develop my Q-Learning rover and maybe go on to from Q-Learning to genetic algorithms, take my soil spirit SIP and increase the size of it so that way I can actually try this out on a farm. And then maybe do some more with the bionic finger and look a bit more into swarm robotics and kind of get into that and really dive into autonomous systems and how to make these things even smarter. Thank you very much. If you have any questions, feel free to reach out whenever.